had 8 over 24. Once again, we know that this is the same thing as 8 over 3 times 8, or this is the same thing as 1 over 3 times 8 over 8. The 8's cancel out, and we get this in lowest terms as 1/3. The same exact idea applies to rational expressions. These are rational numbers. Rational expressions are essentially the same thing, but instead of the numerator and our denominator, we can factor out 15 over 5 x plus 15. So what is this going to be equal to? What is this going to be equal to? So the numerator, we can factor as a difference of squares. We have x plus 3 times x minus 3. And in the denominator, we can factor 5 out. So this is 5 times x plus 3. So once again, common factor in the numerator and in the denominator, we can cancel them out. But we touched on this a couple of videos ago. We have to be very careful. We can't cancel them out. We can't say that this is going to be equal to x minus 3 over 5. But we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression undefined. So we could write this as being equal to x minus 3 over 5. But x cannot be equal to negative 3. Negative 3 would make this 0, or it would make this whole thing 0. So this and this whole thing are equivalent. This is not equivalent to this right here, because this is defined at x is equal to negative 3, while this isn't defined at x is equal to negative 3. So to make them the same, I also have to add the extra condition that x cannot equal negative 3. And so likewise over here, if this was a function, if this was, let's say this was, we wrote y is equal to 9x plus 3 over 12x plus 4, we want to graph it. When we simplify it, the temptation is, well, we factor out 3x plus 1 in the numerator and the denominator, they cancel out. The temptation is, well, this is the same graph as y is equal to the constant 3/4, which is just a horizontal line at y is equal to 3/4. But we have to add one condition. We have to exclude the x values that would have made this thing right here equal to 0. And that would have been 0 if x is equal to negative 1/3. The actual number. We can do the exact same thing. They can factor out a 3. This is equal to 3 times 3x plus 1. That's what our numerator is equal to. And our denominator, we can factor out a 4. This is the same thing as 4 times 3x. 3x, 12 divided by 4 is 3. 12x over 4 is 3x. Plus 4 divided by 4 is 1. So here, just like there, the numerator and the denominator have a common factor. In this case, it's 3x plus 1. In this case, it's a rational, it's a variable expression. It's not an actual number. We can do the exact same thing. They cancel out. So if we were to write this rational expression in lowest terms, we can say that this is equal to 3 over 4. That's equal to 3 over 4. Let's do another one. Let's say that we had x squared. Let me see a good one. So let's say we had x squared minus 9 over 5x plus 15 over 5x plus 15. So what is this going to be equal to? What is this going to be equal to? So the numerator, we can factor as a difference of squares. We have x plus 3 times x minus 3. And in the denominator, we can factor 5 out. This is 5 times x plus 3. So once again, common factor in the numerator and in the denominator, we can cancel them out. But we touched on this a couple of videos ago. We have to be very careful. We can't cancel them out. We can't say that this is going to be equal to x minus 3 over 5. But we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression undefined. So we could write this as being equal to x minus 3 over 5. But x cannot be equal to x minus 3 over 5. Touched on this a couple of videos ago. We have to be very careful. We can't cancel them out. We can't say that this is going to be equal to x minus 3 over 5, but we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression over 5, but we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression undefined. But we have to exclude the values of x that over 5, but we have to exclude the values of x that would have made this denominator equal to 0. That would have made the values of x that would have made this denominator equal to a couple of videos ago. We have to be very careful. We can cancel them out. We can say that this is going to be equal to x minus 3 over 5, but we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression undefined. So we could write this as being equal to x minus 3 over 5, but x cannot be equal to negative 3. Negative 3 would make this 0, or it would make this whole thing 0. So this and this whole thing are equivalent. This is not equivalent to this right here, because this is defined at x is equal to negative 3, while this isn't defined at x is equal to negative 3. So to make them the same, I also have to add the extra condition that x cannot equal negative 3. And so likewise over here, if this was a function, if this was, let's say this was, we wrote y is equal to 9x plus 3 over 12x plus 4, and we want to graph it. When we simplify it, the temptation is, well, we factored out a 3x plus 1 in the numerator and the denominator, they cancel out. The temptation is, well, this is the same graph as y is equal to the constant 3/4, which is just a horizontal line at y is equal to 3/4. But we have to add one condition. We have to we have to exclude the x values that would have made this thing right here equal to 0. And that would have been 0 if x is equal to negative 1/3. If x is equal to negative 1/3, this or this denominator would be equal to 0. So even over here, we'd have to say x cannot be equal to negative 1/3. That condition is what really makes that equal to that x cannot be equal to negative 1/3. Let's do a couple more of these, and I'll do these in pink. Let's say that I had x squared plus 6x plus 8 over x squared plus 4x. Actually, even better. Let me do this a little bit. X squared plus 6x plus 5 over x squared minus x minus 2. So once again, we want to factor the numerator and the denominator, just like we did with traditional numbers when we first learned about fractions and lowest terms. So if we factor the numerator, what two numbers, when I multiply them equal 5, and I add them equal 6. Well, the numbers that popped in my head are 5 and 1. So the numerator is x plus 5 times x minus 1. And then our denominator, two numbers, multiply negative 2, add them negative 1. Negative 2 and positive 1 pop out of my head. Negative, this is a positive 1, right? X plus 5 times x plus 1, right? 1 times 5 is 5. 5x plus 1x is 6x. So here we have a positive 1 and a negative 2. So x minus 2 times x plus 1 times x plus 1. So we have a common factor in the one, right? 1 times 5 is 5. 5x plus 1x is 6x. So here we have a positive 1 and a negative 2. So x minus 2 times x plus 1 times x plus 1. So we have a common factor in the numerator and the denominator. These cancel out. So you could say that this is equal to x plus 5 over x minus 2. But for them to really be equal, we have to add the condition. We have to add the condition that x cannot be equal to negative 1. We cannot, because if x is equal to negative 1, this is undefined. We have to add that condition because this by itself is defined at x is equal to negative 1. You could put negative 1 here and you're going to get a number. But this is not defined at x is equal to negative 1. So we have to add this condition for this to truly be equal to that. pause the video and try to add these two rational expressions. Okay, I'm assuming you've had a go at it. Now we can work through this together. So the first thing that you might have hit when you tried to do it is you realize that they have different denominators. And it's hard to add fractions when they have different denominators. You need to rewrite them so that you have a common denominator. And the easiest way to get a common denominator is you can just multiply the two denominators, especially in a case like this where they don't seem to share any factors. Both of these are about as factors you can get, and they don't share anything in common. And so let's set up a common denominator. So this is going to be equal to, something, let's see, it's going to be equal to something over our common denominator. Let's make it 2x, we just another color. So we're going to make it 2x minus 3 times 3x plus 1.
We all move to the beat of our playlists a little differently.
Plus something else.
And with millions of songs to discover on Spotify Premium, it's good to know you can listen without hearing ads.
And so to go from 2x, just 2x minus 3 here, the denominator, to 2x 3 times 3x plus 1, we multiply the denominator by 3x plus 1. So if we do that to the denominator, we don't want to change the value of the rational expression. We'd also do that to the numerator. So the original numerator was 5x. So the original numerator was 5x. And now we're going to multiply it by the 3x plus 1 times 3x plus 1. Notice I didn't change the value of this expression. I multiplied by 3x plus 1 over 3x plus 1, which is 1 as long as 3x plus 1 does not equal 0. So let's do the same thing over here. Over here, I have a denominator of 3x plus 1. I multiplied it by 2x minus 3. So I would take my numerator, which is negative 4x squared, and I would also multiply it by 2x minus 3. 2x minus 3. Let me put parentheses around this so it doesn't look like I'm subtracting 4x squared. And so then I can rewrite all of this business as being equal to, well, in the numerator, I'm going to have 5x times 3x, which is 15x squared, 5x times 1, which is plus 5x, and then over here, just in green, let's see, I can do 4x times 2, negative 4x times 2x, which would be negative 8x squared, and then negative 4x times negative 3, which is plus 12x squared. Figure out what I just did that's wrong. Third power, now so we're able to just add everything, is 2x minus 3 times 3x plus 1, times 3x plus 1, and let's see, how can we simplify this? So this is all going to be equal to, we draw, make sure we recognize it's a rational expression. And so let's see, we can look at, our highest degree term here is the negative 8x to the third. So it's negative 8x to the third power. And then we have a 15x squared, and we also have a 12x squared. We can add those two together. So we can compare upper, and we are all done. Doesn't seem like there's any easy way to simplify this further. You can factor out an x on the numerator, but that's not going to. We are all done. Doesn't seem like. Easy way to simplify this further. You can factor out an x out of the numerator, but that's not going to cancel out with anything in the denominator. It looks like we are all done. We're told divide the polynomial. The form of your answer should either be just a clean polynomial or some polynomial plus some constant over x plus 2 where p of x is a polynomial and k is an integer. Fair enough. And if we were doing this on Khan Academy, this is a screenshot from Khan Academy, we would have to type this in, but we're just going to do it by hand. And like always, pause this video and try to do it on your own before we work through it together. All right, now let's work through it together. And what we're trying to do is divide x plus 2 into 3x to the third power plus 4x squared minus 3x plus 7. And so, like always, we focus on the highest degree terms first. X goes into 3x to the third power how many times? 3x squared times. We want to put that in the second degree column, 3x squared. 3x squared times 2 is 6x squared. 3x squared times x is 3x to the third power. There's something very meditative about algebraic multiplication. Anyway, we want to subtract what we just wrote from what we have up here. So let's subtract. And these characters cancel out, and then 4x squared minus 6x squared is negative 2x squared. Bring down that negative 3x, and now we would want to say, hey, how many times does x go into negative 2x squared? Well, it would go negative 2x times, put that in our first degree column. Negative 2x times 2 is negative 4x. Negative 2x times x is negative 2x squared. Now we want to subtract what we have here in orange from what we have up here in teal. So we either put a negative around the whole thing, or we distribute that negative, and that becomes a positive, that becomes a positive. And so this is equal to, the x squared terms cancel out. Negative 3x plus 4x is just going to be a straight up x. Bring down that 7, x plus 7. How many times does x go into x? Well, one time. So we use a new color here. So how many times does x go into x? It goes one time. Put that in the constant column. 1 times 2 is 2. 1 times x is x. We want to subtract these characters. And we're left with 7 minus 2 is 5. And so we can rewrite this whole thing as, just a little bit of a drum roll, 3x squared minus 2x plus 1 plus the remainder, 5 over x plus 2. One way to think about it is, hey, I have this remainder. I'd have to keep dividing it by x plus 2 if I really want to figure out exactly what this is. Now, if I wanted these expressions to be completely identical, I would put a condition on the domain that x cannot be equal to negative 2, because if x was equal to negative 2, we'd be dividing by 0 here. But for the purposes of this exercise, you just have to input this part right over here. You just have to type it in, which I guess isn't the easiest thing to do in the world, but it's worth doing. All right, see you in the next video.
Take the guilt out of your listening pleasures by indulging in what you love with Premium. Download and listen to ad-free music wherever your day takes you, so it's even easier to tune in to what you really want to hear. Get 1 month of Spotify Premium free. Tap the banner to learn more. need something to keep the peace. The Spotify Premium Family Plan gives everyone under the same roof equal listening freedom with separate accounts. Each person can enjoy the premium perks of offline and ad-free music listening from anywhere. Plus, explore music recommendations tailored to your tastes. Tap the banner to learn more.